Hello and welcome to Unbuilt Giants, a series that looks at the development and demise of some of history's most notable and sometimes bizarre skyscraper projects. The Millennium Challenge Tower, also known as the Al Jaber Tower, was an ambitious architectural concept proposed by Italian architect Omero Marchetti as part of his Millennium Challenge 1852 project. Envisioned to rise a full nautical mile, this vertical city would have dwarfed every existing skyscraper, including Dubai's Burj Khalifa, redefining the limits of urban construction. Designed as a self-sustaining habitat capable of generating its own energy and even transforming surrounding desert into fertile land, the tower aimed to merge visionary engineering with environmental responsibility. Though it remained unbuilt, the Millennium Challenge Tower stands as one of the most audacious and imaginative skyscraper proposals ever conceived. The Millennium Challenge Tower, which also became known as the Al Jaber Tower, emerged as an ambitious and imaginative architectural concept in the early years of the 2000s, a period when global interest in extreme skyscraper design was beginning to intensify. This visionary project was the creation of Italian architect Omero Marchetti, the founder of the Millennium Challenge 1852 project, whose ideas sought to challenge not only the limits of engineering, but also the prevailing approach to urban development and environmental responsibility. The proposed tower was planned to reach a height of 1,852 meters or 6,076 feet, which corresponds exactly to a full nautical mile, an extraordinary measurement that symbolized its aspiration to redefine the skyline and the very concept of vertical living. At over 6,000 feet tall, the structure would have been dramatically taller than any skyscraper of its era, dwarfing the world's most iconic high-rises, including Dubai's Burj Khalifa, which soars to 2,722 feet, and New York's Freedom Tower, standing at 1,776 feet. Its proposed scale placed it firmly in the realm of both architectural speculation and futuristic urban planning, representing not only a building, but a statement of technological and environmental ambition. From the outset, the Millennium Challenge Tower was linked to Kuwait as a potential host country, a nation known for its desert landscapes and rapidly developing urban centers. Kuwait's ambitions to establish itself as a hub for architectural innovation and global prestige made it a fitting candidate for such a landmark, which, if realized, would have instantly become the tallest structure on Earth and a defining symbol of human ingenuity. Yet despite its association with Kuwait and the promotional references to the tower as the Al Jaber Tower, no precise site had been confirmed, and discussions about its exact placement were still speculative prior to 2004. This uncertainty reflected both the complexity of the project and the challenges of situating such a monumental construction in a way that balanced engineering feasibility, environmental considerations, and the symbolic impact that its creator intended. The proposed structure is envisioned as a true vertical city, a self-sufficient urban environment rising into the sky. It is designed to support not only its inhabitants, but also the surrounding landscape by employing a sophisticated water management system capable of fertilizing and revitalizing 25 square kilometers of barren desert. This reclaimed land would sustain a network of trees and plant life, creating a living oasis in what was once arid terrain. These trees would provide a continuous source of oxygen for the tower's residents, forming a vital, self-sustaining ecosystem that links the life of the building to the health of the environment around it. The concept imagines a city that does not sprawl outward, consuming land and leaving wastelands in its wake, but rather grows vertically, symbiotically tied to the land it occupies. Unlike conventional skyscrapers, this tower is not designed to be assembled in the traditional manner. Instead, it would grow in segments, rising section by section in a process likened to the unfolding of a flower. Each stage of construction would employ advanced engineering techniques drawn from disciplines far beyond standard civil engineering. Inspiration comes from the fields of aeronautics, automotive innovation, and high-precision industrial manufacturing, where lightweight yet durable materials and modular systems are the norm. By rejecting the ancient reliance on brick, concrete, and mortar, materials whose origins stretch back thousands of years, the design seeks to transcend the limitations of weight, rigidity, and inefficiency that would make a conventional structure of this height impossible. Omero Marchetti, the architect behind the project, has firmly rejected the use of orthogonal grids, conventional cranes, and other long-standing construction methods. He argues that at a height of 1,852 meters, the forces and stresses on such a building would render traditional methods impractical and even dangerous. The colossal quantities of concrete and iron required would inevitably be bent into unnatural and twisted geometries, compromising stability. To overcome these challenges, the tower adopts a structural logic drawn from nature itself, employing hexagonal matrices inspired by the geometry of snowflakes. These interlocking hexagons achieve a remarkable balance of strength and lightness, enabling the creation of a high-volume, low-weight framework that minimizes stress and distributes loads efficiently. In keeping with this philosophy, the building eliminates right angles and perpendicular planes altogether, since these forms generate structural weaknesses at an extreme scale. This organic, flowing geometry provides both resilience and elegance, turning engineering necessity into aesthetic expression. Sustainability is embedded not only in the tower's daily functioning, but in its long-term life cycle. A key aspect of the proposal is a comprehensive end-of-life plan, ensuring that the entire structure can eventually be dismantled in a methodical and environmentally responsible manner. Every component is intended to be reusable, returning valuable raw materials to future generations rather than leaving behind waste or dereliction. The building will incorporate a highly advanced maintenance system capable of keeping every part of the vertical city operational and up-to-date. Energy will be generated from renewable sources, including the sun, the wind, and collected rainwater, while internal systems will recycle and optimize resources to reduce external demands. Even the internal layouts and surface finishes are conceived as adaptable, allowing the city to evolve over decades without the need for demolition or disruptive reconstruction. Despite its extraordinary ambition and the early interest expressed by 3 separate investor groups, the Millennium Challenge Tower was never realized. The reasons for its failure were rooted in the profound technical, financial, and logistical barriers posed by a project of such unprecedented scale. Omero Marchetti's design far surpassed any structure ever attempted, and this demanded engineering solutions that went far beyond the capabilities of conventional construction methods. This departure from established building practices created challenges in cost, feasibility, and coordination that proved insurmountable. Financial considerations were equally prohibitive. Even with expressions of interest from potential backers, the cost of research, development, materials, and labor would have been astronomical, with no precedent for calculating realistic returns on such an investment. The lack of a clearly designated site compounded these issues. While Kuwait was frequently mentioned as a possible home for the tower, no official location was ever selected, and without land secured, formal planning permissions, or governmental commitments, the project remains suspended in a purely conceptual phase. As months and then years passed without progress, investor interest waned, leaving the scheme stranded between visionary aspiration and practical impossibility. The Millennium Challenge Tower was imagined as a vertical city capable of reshaping both architecture and urban living, with self-sustaining systems, environmental regeneration, and the ability to be dismantled and fully recycled at the end of its life. Yet without the convergence of extraordinary resources, cutting-edge technology, and firm political will, it could never advance beyond its role as an ambitious design study. Over time, the tower became an emblem of the limits of visionary architecture, a reminder that imagination alone cannot overcome the immense constraints of physics, economics, and urban planning. It lingers as a symbol of what could have been, a soaring mechanical flower intended to transform the desert and redeem the mistakes of modern cities, but ultimately left to exist only in drawings, proposals, and the minds of those captivated by the dream. Thank you very much for watching this video. If you enjoyed it, please hit the like button and consider subscribing for more episodes coming soon. See you next time.